Hello everybody, my name is Rohit. I'm currently in my 8th semester of mechanical engineering. My project is at a firm called O9 Solutions. My project is utilization of data analytics and artificial intelligence for supply and demand planning. This is my work progress so far. The first 4 tasks have been completed. The fifth tasks or the fifth work, which is the application of AI and statistical models to enable forecasting of consumption of raw materials in a plant based on historical consumption data, is 90% completed, and I would require a week more or so to finish it off. These are the methodologies I have utilized to complete my work. The first 5 have been explained in the previous presentations. The sixth one, however, is a new addition, and I had to utilize the Empower platform along with the R server and the R studio to implement this task. I utilized the Empower platform to obtain the information and to present the information, and this was integrated with the R server where the processing took place. I had to write the code and test the code on R studio to see if it was working. From this slide on, I'll be explaining the complete methodology which I took to complete my work. I'll start off with a conversion of planned week to split week demand quantity. So this is how my input Excel file looks like. I extracted this information from the NPOF platform using query commands. As you can see, there is the item column, location column, then there is the time.fiscal week column, which gives us a day this item was used in so and so location, and there is the beginning on hand, ending on hand, which are inventory related terms, and then there's the important one, that is the demand quantity. That is the demand that is going to arise for that item in that particular location on that particular day. So this is a commonly used Excel file in the company. Like, they extract information in this form, and this is called the planned week format, where the demand is calculated on days starting from a certain day of the year, followed by every 7 days from that day in the entire year. For example, you can see that the special day is 2nd Feb 2020. From there on, it is every 7 day, that is 9, 16, 23rd, so on. So they wanted it in a form called the split week format, which again used by a lot many people. So what happens in split week format is the pattern I can see here is also present along with demands calculated on the first day of the month, the 8th day of the month, the 15th day of the month, the 22nd day of the month, and the 29th day. That is 7 days gap from the first day of the month. That is first, 8th, 15th, 22nd, 29th. So the demand that has been planned for according to the planned week format has to be changed to accommodate the split week format as well. So this should be my, so what my code required to do is this input file, that is the planned week format, should be converted to split week format upon execution of my code. And this is how the output looks like. Once my code has been executed, when we feed it with the input, the final output should be as such. As you can see, the demand quantity has changed, as well as the dates. on which the demand is being calculated. For instance, new day, after 2nd Feb, it is 8th Feb which has come into existence, followed by 9th, which is already there, and again 15th Feb, then 16th as usual, and so on. So the value that we saw for 2nd Feb in the previous slide was 4,680, but now it has changed. So what the code required to do was to split the demand between 2nd Feb and 8th Feb according to a ratio. The demand that was there present 4,680 was for 7 days in total, that is from 2nd Feb to 9th Feb. But now since 8th Feb is being generated, the demand now will which has to be present on 2nd Feb will be for 6 days. So the ratio will be 6/7 of the initial value, and the remaining value will go to 8th Feb. So this is how the split week format is calculated. Now this has to be done automatically for all items, for all locations, and the date should be ordered as such. And this is what my code does. It receives an input file like the one we saw in the previous slide and converts it into the file which we're seeing now. And this is helpful for the employees in the company because they don't need to manually keep doing it now, and they can run my code whenever there's a requirement for conversion from planned week to split week. This is a screenshot of my code that I've utilized for the conversion from planned week to split week. If you can observe that the first line, there's something called the planning quantity, and that has been given a read CSV command, that is, it takes an input, and then there's a function called converter which is executed, and in the after this function converter has been executed, a final output file is created, which is the split week format. Now this is my second task, you can say, that is creation of DSI alert system for past and future dates. And this is the way I implemented it. That is, first, the real-time inventory data has to be uploaded onto the platform. Then the data is processed and checked continuously on the platform based on the code I have written. And the third is the alert system will create a report in case of any discrepancy in the inventory. That is, if there's an understock or an overstock, it automatically shoots a mail to the client stating that, okay, this item at this location is not at the desired level. There is a problem with this item and some care has to be taken. So that is the use of this alert system. This is a screenshot of the code I've used to execute this alert system. It calculates the average based on the past historical data for the next 30 days from the current day. So we should, so it gives an idea what the inventory is going to be for, or what the inventory has to maintain for the next 30 days from the current day. And if there is any discrepancy in any item, like if there's an understock and overstock, then the flag is raised and the client gets to know about this. Now coming to the most important task of my project so far, that is the application of artificial intelligence and statistical models to enable forecasting. And this is a flow chart of how I proceeded with my work. First, I received the historical consumption data of various raw materials used in all the plants of the company, and then I need to select the most suitable statistical model for forecasting, obviously. The criteria for selection is based on a parameter called RMSE, which stands for root mean squared error. What this checks is, it checks the forecasted value with the actual sales value, and it tries to minimize it as much as possible. So we need to choose a model where RMSE is the least, where the error is the least, in other words. And once you've selected the perfect model for our data, we have to implement it. So what we do is we obtain the time series of raw material consumption and process it in the R software. And once we process it and compute it according to our parameters, our forecast is obtained for the next 180 days from the current day. Now this forecast is then uploaded onto the Empower platform, which the client can easily access. Now, after thorough checking and a lot of verification, validation, and theoretical support, I shortlisted the number of models that are suitable for a data to two. That is the ARIMA, which stands for Auto Regression Integrated Moving Average. I felt this would be suitable for handling aggregated data consumption. And when I say aggregated data consumption, it means all the raw materials consumed, irrespective of item, irrespective of location, on a given day, is nothing but aggregated data consumption. That is the total data consumption on a given day. And the best model to process this data was the ARIMA model. Why this was the best model? One reason would be the RMSE is the lowest. Second is that it is able to pick up the seasonality and the trend in the data, which is important. After picking up the seasonality and trend, it's able to give us a forecast which has a very good accuracy. You can say not, I cannot say it's 100% accurate, but greater than 75% accuracy, which is what the clients are expecting. What the ARIMA does is it provides different weightages to different data points in the historical data. That is, it sets a weightage, higher weightage to more recent data than the older data. Then it ignores the outliers. So it's a ready-made model in R that checks the data and makes the best model that can forecast from it. So ARIMA sets the parameters automatically so as to obtain the best results. And by best results, I mean the lowest RMSE values. The second model that we'll have to use is the neural networks. The problem with ARIMA is that it cannot handle certain time series data. For instance, if you want the forecast for one item which has to be which is consumed in one plant, then the ARIMA model is not the most suitable model because there will be many zeros in the consumption. When I mean zeros, what happens is the materials or the raw materials are not consumed every day. For example, let us say a lubricant is being consumed. On the first day, around 120 might be consumed. Then next 4 days, there won't be any consumption of the raw material. And then on the fifth day, there might be another 50 consumed. Then after 6 days, another 6 days, there won't be any consumption. And then the 12th day, again, there might be consumption, so on. Such kind of time series is called an intermittent time series. As the name suggests, the consumption is not continuous and intermittent in nature. For such time series, ARIMA model is not a suitable model. So in that place, we need to use neural networks. Neural networks are similar, are inspired by how a brain thinks. The neural networks are comprised in the form of nerves of data. How do I explain this? It's a data model or a machine learning model which uses artificial intelligence to give the most accurate results. So how does it do this? It does this by continuously correcting itself. It produces a result based on certain parameters. Then it checks it with the actual values which we feed it. It checks the difference in the actual value and the predicted values. Then again goes back, checks, tinkers with its parameters, and comes back with values, checks it again, and continuously does this process until the error is minimum. So that is what neural networks is. This is the code that I've utilized for implementing the forecasting. I receive the historical data from the Empower platform, process it on R, obtain the forecasted values, and export it again into Empower platform. And this is how it looks. The graph in red, or the chart in red, you see, is the historical data consumption. And if you look closely, the graph in green is the forecasted model. There are various other charts, please ignore them. That is the blue one and the purple one that are not necessary right now. They have certain other parameters, but the forecasted data is the one in green. So you can see that there is a similarity, or when you see it from naked eye, there is a continuation of data. That shows that the forecast is good. It is forecasting it to a reasonably accurate level.